definite integration using the property of definite integration 0 to a f of x equals to 0 to a f of a minus x dx. By using this property, we will solve a special type of question, removal of x. Removal of x from x into f of x, where integration f of x is known. On using this, we take some example. Evaluate integration 0 to pi x tan x whole upon sec x plus tan x dx. In this integration, if x is removed, then tan x upon sec x plus tan x easily integrated. So this integration is known to us. So our problem is remove to x. If x is removed, then the question is becomes very easy. Using the property of x, our property of definite integration, we will remove the x. So using the property 0 to a f of x equal to f of a minus x dx. So I equals to 0 to pi. Now remove x, so apply the property. In place of x, write pi minus x. Pi minus x tan of pi minus x upon sec of x, replace pi minus x. Pi minus x plus tan of pi minus x dx. This is our relation number 1. So I equals to 0 to pi. Tan pi minus x is minus tan of x. So this numerator becomes minus pi minus x into tan of x whole upon sec pi minus x is minus sec of x secant, and again tan pi minus x is minus tan x. So I equals to 0 to pi. Now taking pi minus common from denominator, so minus pi minus x into 10x and taking minus common, so this becomes sec x plus 10x. so ये कैंसल हो गया, माइनस माइनस कैंसल. now I equals to 0 to pi. Now our integrate becomes, open the bracket, pi 10x minus x 10x whole upon sec x plus 10x. Whenever we use the property, this is relation to, whenever we use the property, this is star property, 0 to a, f of a minus x equal to f of x, denominator is same. So on adding, our integrate becomes very simple. So on adding 1 and 2, so 2y equals to 0 to pi, denominator is same, sec x plus 10x, so write down numerator as it is. On adding in 1 x 10x x 10x from 1 and from second plus pi 10x minus x 10x whole upon sec x plus 10x, denominator is same. So this is the use of property. Our integration becomes very simple now. X 10x negative, positive cancel, so twice I equals to 0 to pi 10x sec x plus upon sec x plus 10x. So pi is constant taken out, so our question becomes 10x upon sec x plus 10x. So our hurdle is removed. तकलीफ किसकी थी? x की थी, वो x रिमूव हो गया. Now 10x upon sec x plus 10x is integrable very easily. We know the trigonometric identity sec square x minus tan square x is 1. So multiplied and divide denominator by the opposite sign of this. If here is plus, then multiplied by minus. If sec x minus tan x is here, then multiplied by sec x plus tan x. So here we will multiply numerator and denominator by sec x minus tan x. Twice I equals to pi 0 to pi 10x into sec x minus 10x upon sec x plus 10x into sec x minus 10x dx. So twice I equals to pi 0 to pi. Now sec square x minus a plus b a plus b into a minus b is a square minus b square. So this becomes sec square x minus tan square x. Sec square x minus tan square x, and this is equal to 1. So our denominator becomes 1. So now our question becomes, now open the bracket from the numerator. So tan x into sec x minus tan square x, and denominator is 1. So twice I pi into 0 to pi tan x sec x, integration of tan x sec x minus, now tan square x may be written as 0 to pi tan square x is sec square x minus 1. So sec square x minus 1 is integrable. So twice I equals to pi. Now tan x sec x, integration of tan x sec x is sec x. Limit 0 to pi minus integration of sec square x is tan x. And integration of 1 is x, 0 to pi. So twice I equals to pi into whole bracket, upper limit minus lower limit. So sec pi minus lower limit 0, sec 0. Now minus tan pi minus pi, and lower limit 0, so tan 0 0 and x is 0, so it is 0. So our entire question becomes twice I equals to pi into, now put the values, sec pi minus 1 minus sec 0 1 minus tan pi 0 and minus plus pi. So twice I equals to pi into minus 2 plus pi. So I equals to divide by 2, pi by 2 into, right, pi minus 2. Answer. Okay, thank you.